Hi, today's lesson is powers and exponents. Our standard is 6EE1, write and evaluate numerical expressions involving whole number exponents. I can understand exponent notation and use exponents in order of operations problems. So we're starting our expression unit with exponents.
All right, we've got some notes to write down here. Start off with our definition up top, powers and exponents. It's kind of the two different ways of talking about the same thing. Exponents are used to represent repeated multiplication, multiplying the same number over and over and over again.
You're going to click.
We call that the factor that's being multiplied together. So there's our big number and our little number. The big number is our base. It's the number that's being multiplied over and over again. So in this case, we're going to have a bunch of 5s multiplied together. The smaller elevated number is our exponent. We're not multiplying by the 4. The 4 is just telling us how many 5s are being all multiplied together.
So when we write this out, we're really talking about 5 times 5 times 5 times 5. 5 is the base that needs to be multiplied 4 times, which is what the exponent is talking about in the little tiny print on the right side of the number.
Here's what you don't want to do. You don't want to just multiply those two numbers together. This is not 5 times 4. As Mrs. King just said, it's 4 5s all being multiplied together.
You're going to really need to slow down. 5 times 5 is 25 times 5. You guys tend to rush on these powers problems.
So let's practice going in both directions here. So first is trying to say one of these in words, kind of how would we say it? We would say 2 to the 6th power.
Going to write all that out. And sometimes the directions say write each power as the product of the same factor. Product meaning multiplication. And we just talked about that factor or that base. So we're going to write the 2 to the 6th power as a repeated multiplication problem. So 2 is our base, so we want to put 2 multiplied 6 times. So he used his fancy little lines to show you that he needs 6 of them. It's 2 times 2, which is 4, times 2, which is 8, and so on. It didn't ask us to solve or evaluate it, but that's how we would do it if the directions told us to do that.
I was waiting to see if she would multiply it all the way out.
No. I mean, I can, but waste time.
So here, we would say this one is 3 to the 5th power. So remember, the exponent is just how many 3s are being multiplied. So I went 5 3s. 1, 2, 3, 4, 5. Each of them is going to be a 3 multiplied together. So a good way to check is look at your exponent, count how many 3s are you multiplying. That should match up with your exponent. Notice a 5 never showed up anywhere in the actual problem itself.
Okay, we're going to go the reverse with the directions. We're going to write the 4 times 4 times 4 times 4 using a base and an exponent. So 4 is my number that's being repeated. So 4 is my base. It's being repeated 4 times. So I need a little 4 in the top right-hand corner. So 4 to the 4th power, and then find its value. So I need to go back and solve it. 4 times 4 is 16. 16 times 4 is 64. And 64 times 4, oh my gosh, 256? 256, mental math day, wow.
Next one, we have 6 times 6 times 6. So the base, the big number, is the number being multiplied. So we're multiplying a bunch of 6s. There are 1, 2, 3 of them being multiplied together. So my exponent is to the 3rd power. See if I did my math correctly. 6 times 6 is 36. Times 6 is 216.
I'll do the next one for you. So 1 would be our base, because that's the number being multiplied in the repeated multiplication. We have 1, 2, 3, 4, 5, 6, 7. 1 to the 7th power is 1. My favorite power. All right, in the next two examples, we're talking about in math terms, we have special names for when something is squared or cubed. So 8 squared, or any number to the 2nd power, is squared, and it comes from what you guys discussed in the elementary school, that base times height or length times width when our units were squared for area. We're going to talk about that in the geometry unit. So anything to the 2nd power is squared.
anything cubed, think of a cube. It's got 3.
Can he draw one? Mr. Rubik's Cube.
That's pretty good.
Maybe.
A cube has 3 dimensions. When we get to volume, we're going to talk about our units are cubed. 1, 2, 3 dimensions. So 4 to the 3rd power is what 4 cubed translates to be.
6 to the 3rd power would have been 6 cubed.
So we could have called that one 6 cubed as well up there.
Previous example. All right, now let's apply it to our order of operations problem, remembering our pyramid that we made the other day. Our parentheses need to come first.
Sorry, it's a really bad
Grouping
pyramid.
symbols, followed by our exponents, which is what we're doing today. Multiplication and division go hand in hand, and lastly, addition and subtraction.
I'll just extend it a little bit.
I would have done the same thing. So in our first problem, we have no grouping symbols, so our first step would be the 6 squared. Remember, that is not 6 times 2, that's 6 times 6. So we're going to do that first, and we're going to make that 36. We're left with multiplication and addition, so he's going to simplify his work. Our next step would be the multiply 36 times 3.
That should be, what, 108?
I thought you were going to force them to show their work, but that's fine. And 108 plus 4 is 112. And I'm done with the problem.
All right, I gave her the easy one. Next one, we have 4 cubed minus, and then in parentheses, 6 times 8, and then the whole thing divided by 12. So start at the top of the pyramid with our grouping symbols. Our parentheses, 6 times 8, that is 48. We rewrite the rest of the problem. We're done with parentheses, so now we look at our exponents. 4 to the 3rd power.
It's not 12.
Do not do 4 times 3. It's really 4 times 4 times 4. So I kind of like to write that above my exponent to help me remember what I'm supposed to be multiplying. 4 times 4 is 16, times 4 is 64.
Now do not subtract first. Think about what you're doing.
So we're done with parentheses, we're done with exponents. Now we do our multiply and divide. We do have some division. So 48 divided by 12 is 4. Everything else just slides down. And then we're left with our adding and subtracting. 64 minus 4 gives us 60. And that's how we include our exponents in our order of operation problems.
See you tomorrow.